can compute what you call your so this is like bootstrapping actually. I mean, if you think actually what you are doing, you know, you are bootstrapping the value of the next step, you know, a plus h a little bit from your what do you call previous value. Okay, from your what do you call the previous value. So we can make we can do similar kind of. So there are several simple examples actually what you can do in this similar manner. You can find it. So in other words, this linear approximation is really useful. So when you are approximating a curve by a tangent line, since we know the tangent line and since we extract the values from the tangent line, you can extract the approximate value of the curves actually. Okay, because the curves locally can be approximated by the tangent line on the point actually. Okay, so similarly you have some simple exercises. So this was one of the example where you can compute the value at a new, obviously, you know, the more closer you are to, for example, your previous value, the better result you're gonna get actually. Okay, but the more you are away, so in other words, if I have a sine 0 and I want, for example, sine 10, then that's a huge interval actually that you are trying to. So, you know, can sine be approximated between, for example, you know, 0 to pi by a straight line? So it's not a good strategy actually that, okay, you approximate because, you know, the function oscillates actually. Okay, so a good approximation is going to be a good approximation if it is, you know, valid for small intervals actually. So in other words, you know, this strategy would work if h is small enough. If you're gonna choose big h, there will be more error actually. Okay, in your previous value. Okay, so if you want the value of function at a new point, then take your previous point and plus add this quantity. So you're gonna get the value of the function at your new point or neighboring point actually. So this is really the bootstrapping actually, that how you can take your previous value and approximate and predict your, you know, upcoming values for the function actually. So there are several such examples given for this. So you also have to figure out some of the examples and exercises from using the same strategy from the book actually. So we can continue these discussions more on in our next session actually. Thank you.